All right, can we see? So let's do some population calculations. All right. So I'm starting at the very beginning here, just really basic for anybody who is completely confused. And then we're going to do some more advanced problems, and then I made up some problems. Now you can just, kind of go ahead if you notice like this is too easy, like you already know this. Okay, let's start at the beginning. So number one, there's 1,260 deer living on an island that is 840 square kilometers in size. What is the population density of the deer per square kilometer? So they even give you a clue as to how to set it up. It tells you number of deer per square kilometer. So we have 1,260 deer per 840 kilometers squared. Okay, so just setting it up, figuring out how to set it up and doing it gets you a point. So then you actually can do the division, 1,260 divided by 840, and you find 1.5. So this is 1.5 deer per square kilometer. So that's density in terms of population, number of organisms per unit area. Okay, so let's go to number 2. It says a city with 52,000 people has 260 births. What is the birth rate as a percentage and per thousand? CBR. CBR is per thousand. So we're talking about CBR, CDR, and we're going to calculate population growth rate, and there's also immigration and emigration and doubling time. So CBR is really the number of births per 1,000 people in the population. Okay, but we don't really write the number 1,000. So what we would do here is, it tells us there's 52,000 people in the population. This is the same as 52 times 1,000, right? So it means there's 52 thousands. And this is any 1,000 people in the population. It's just a random 1,000. So how many births are there for every 1,000 people in the population, for every 52,000? So we take the number of births, 260, divide that by 52. Remember, that's 1,000. I'll write the word just so you know it's kind of there. So 260 divided by 52. 1,000. Okay, so 260 divided by 52. And you'll notice this is nice and easy. 5 times 2, 26. Okay, so 5. And this is 5 per 1,000, but we don't write it that way. It's just 5. But we know when we are given CBR, you're asked for CBR, and there's a number, you know that that's per 1,000 in the population. For every 1,000 people in that population, there's 5 births. Okay, so let's go on to number 3. So here's another city, and actually they tell us the CDR. It's 12 deaths for each 1,000 people. That's 12 deaths for every 1,000. So that just means our CDR is 12. And that's for every 1,000. You know what? I forgot to do the percent here. We don't usually just do like the percent births or percent birth rate, but let's go back to this and talk about that quickly. So remember that this is, the CBR is 5 per 1,000. It also means 5 per 1,000 people. So percent is just out of 100, right? So the way that you do this is, well, you would eliminate the decimal places. So it's like you divide the top and the bottom by 10. So there, move that over, and that's 0.5. And that's now a percent because it's 0.5 out of 100. So percent is, some number out of 100. This is now 0.5 for every 100, and that makes sense. If 5 out of 1,000 equals 0.5 out of 100. So because we don't write 1,000, when we present CBR, it's just the number 5. You take that number 5 and you divide by 10 to find the percent. Okay, so, but this is how you think about it so that it makes sense. I hopefully that makes sense to you. So over here then, the CDR, remember, is 12 per 1,000. So how many is that per 100? So in other words, percent, right? Percent is per 100. So you just take 12, divide by 10, and that makes it then 1.2 per 100, which is the same as 1.2%. I hope that makes sense. But at least you know how to calculate CDR and CBR, okay? Because they don't often ask for the birth rate as a percent or death rate as a percent. Okay, so let's look at number 4. So in number 4, it says a village has 25,000 people. There's 750 births, 525 deaths. And so we need to find the growth rate for this village. So the formula for growth rate, you have to memorize it. It's CBR minus CDR. So it's the crude birth rate minus crude death rate. And it makes sense because births are coming in, deaths are going out of the population. And the full formula is then the immigration rate, which is kind of the net immigration rate, or you could think of it as crude immigration rate, minus the crude or net emigration rate, or just the emigration rate. And this whole thing divided by 10. Because I'm not going to explain that again. It's just divided by 10. Okay. So the thing is, if we don't have any immigration, so in other words, or any emigration, so the migration is net 0, then this part just kind of goes away, right? And we're just left with CBR minus CDR divided by 10, because this is 0. So in this case, that's what it looks like. They didn't mention any immigration or emigration. So we're just going to do CBR minus CDR divided by 10. Now we don't have the CBR or CDR yet. We just have the total number of births, total number of deaths. And we do have the total population. So let's figure out what the CBR is first. So CBR, remember, we go the total number of births divided by the number of thousands. We have 25,000 in the population, so 750 divided by 25. And that then is 30. So the CDR is total number of deaths divided by the number of thousands in this population, which is 25. So that is 21. Okay. I could do that in my head. If you have to do it out. That's okay. I've already done this problem a few times. So now we plug it in to this part of our formula because we don't have any migration. So 30 minus 21, okay, divided by 10. So that's 9 divided by 10, which is 0.9%. So this is the growth rate for this country. So then in number 5, it asks, well, how long will it take for the population of this country to double? It says to go from 25,000 to 50,000, but that means to double, right? Okay. So we use the formula for doubling time. So that's number of years to double equals 70 over the population growth rate. It's also called the rule of 70. So we'll just take the 70 divided by 0.9% and you solve for that. And when you do that, it came out to be, it was 77.77 repeating, which equals 78 years. So it'll take 78 years for the population in the village in number 4 to double at this rate, right? Okay, so this is, the essentials, the basics. So let's, I want to go ahead, use what we did here to help you to solve all these other problems. I want to go on to number 13. Okay, I did this in class, but let's go over it now again. So number 13, there it tells us there's 300 million people in the population of this country, 125,500 deaths, 535,500 births, don't mix them up, and a net migration, now this is not a rate, right? Net migration of plus 10,000, that's key. It's not a rate. Previously, no, we didn't have a migration rate, never mind. Okay, so 300 million, now we need to know how many thousands are in 300 million. So you should write this out. Okay, there, that's 300 million. So there are 300,000 thousands in 1 million, right? That's the same thing as 300,000 times 1,000. So to figure out the CDR and the CBR and the net migration rate, we're going to take each of these numbers and divide them by 300,000. So we'll do CDR first. CDR equals 125,500 deaths per, that was total, right? Per 300,000 in the population. So this is for every 300,000 people right now. So when we divide that, I'm going to take a shortcut and check answers. I mean, you know, you do the work. Oh. And we get 0.42. I rounded slightly. Okay, and our CBR equals 535,500 total births over 300,000. So equals 1.8. And then for our net migrants, so we need net migration rate. I'm going to take the 10,000 divide by 300,000. So, you know, when you're doing this, if you're doing this by hand, you can eliminate a whole bunch of the decimals. It's really just 1 over 30. So 0.03. I hope I'm doing this right. Okay, and remember, the net migration was positive, which means that there's more immigrants than emigrants. So what we do now is I'm going to use this formula from previously, and this is net, right? I mean, this whole thing in the parentheses here is net. So, oh no, that's supposed to be a plus. Well, we didn't do this yet, so I hope I didn't screw that up, but this is supposed to be a positive. I hope I didn't screw that up for you, right? Because we want to add the number of immigrants. So what we're going to do is take 1.8, the CBR, minus the CDR, 0.42, plus, and whatever the net migration rate is. So if it was a negative number, you would be adding a negative, so you would be subtracting. Okay, I came back. As I was afraid of, I ran out of memory and I had to delete something. So you missed a little bit. So let's pick up where I left off. So what I did was I took the CBR, subtracting the CDR, and then adding, here it is, the net migration rate, which we determined by taking the number of immigrants net, or migrants, I guess we could say, net, and it turns out it's plus 10,000, which means there's more immigrants than emigrants. Divide that by the number of 1,000 people in the population, we got 0.03. Well, so 1.8 minus 0.42 plus 0.03. Divide that by 10 and you get 0.14%. That's okay, it's a decimal. Populations can grow very slowly. Okay, we saw 0.9 before, close to 1. This is very low. So we need to determine the number of years to double. We use this same formula as before. I already did it. You missed it. So here's the 0.14%. Number of years to double. Take 70 divided by 0.14%. I multiplied the top and the bottom by 100 to get rid of the decimal on the bottom. It's the same thing. 70 over 0.14 equals 7,000 over 14. It's the same thing, right? So when I did that, I got 500 years. So that's a long time for a population to double. A very slow growing population. So why don't we do like a problem where you're not really, you have to do all of the work. So let's see, I was doing a little research looking up some countries and their numbers, demographic numbers, and I thought I could make some, real problems. So let's look at Afghanistan. So these are numbers for mid-year 2018, actual population numbers. So Afghanistan had a population of 34,941,000 people. There were 1,292,817 births, 454,233 deaths, and the net migration rate is -1. So this is already done for us. This means for every 1,000 people, there's one person net leaving. So I mean, there may be some people coming in, but there's just one more person per 1,000 who's leaving than coming in. So the first step is to figure out, yeah. So what do we want to do? Well, let's figure out the population growth rate, which I already know because the website said it, but we'll like double check it. And then we can determine the number of years for the population of Afghanistan to double. So the CBR, remember, take the number of births, 1,292,817, divided by the number of thousands of people in the population. So here it is, 34,941. This will give us our CBR. And when you do that division, I already did it, it's 37. Okay, so CDR, you take the number of deaths, total number of deaths over the number of thousand in the population, do that division, and found it's 13. Okay, so actually we have everything we need now to figure out the population growth rate. So 37 minus 13, CBR minus CDR, plus, right, plus, not minus, the net migration rate, which is -1. And that is divided by 10. So 37 minus 13 would be 24 plus a -1, 23, right, over 10, which equals then 2.3%. Uh-oh. Well, the census site said 2.4%, so there's probably some rounding involved there. I'm pretty sure I did this. It looks right. So I better double check. Yeah. Okay. So some rounding. That made the number different. So 2.3%. Now, how many years would it take for the population to double? 70 divided by 2.3%. Okay, if, you know, we could do it like times 10 times 10, so it's 700 divided by 23 when you do it by hand. So it'll be easier. Okay, so $30.4 years will round up to 31 years it will take for the population to double. Okay, so that was, remember, given this many people in the population, this many births, this many deaths, and the net migration rate. We were able to figure out CBR, CDR, growth rate, and doubling time. Let's try another. I'll give you another problem. Okay, gonna make this a little bit more challenging. So, actually I haven't practiced this particular problem yet. What if I told you that for Japan, the population was 126,168,000 in mid-2018. So the CBR is 8. Net migration is 0. The growth rate, negative 0.2, and that would be a percent. What's missing? It's the CDR. So what is the CDR for Japan? Well, let's plug in our calculation here. So we've got 8 minus CDR, right? Plus the net migration rate, which is 0, so nothing really, divided by 10 equals negative 0.2%. So now we have to solve for the CDR. So to simplify this, 8 minus CDR, and just get rid of that migration rate, equals negative 0.2%. So multiply both sides by 10. 8 minus CDR equals negative 2 What happens to the percent? I don't know. It's just not percent anymore, I guess. So now, what can we do to get rid of these negatives? Add plus 2. This is tricky. Plus CDR. Oh, well, I mean, just looking at it. Let's try this. Plus CDR. Plus CDR. So 8 equals -2 plus CDR. Rearrange that to CDR minus 2 equals 8. And so the CDR, and plus 2 on this side, plus 2 on this side, 10 equals the CDR. Okay, so the crude death rate is 10. And there's crude death rate is 10, and crude birth rate was 8. Okay, so there's more deaths than births per 1,000 people, and that's why we have a negative growth rate with a net zero migration rate. So if Japan wanted to increase its population, it could encourage people to have children, or it could encourage people to immigrate, right? Or both. So you can see that there's a lot of combinations of problems that you could get where you have to solve for something in the formula given the growth rate. Oh, so anyway, you might be curious, what would be the doubling time for Japan at this rate? So 70 divided by negative 0.2%. And so 70 divided by 0.2 gives you 350 years. But the problem is, this is a negative number. So actually, that's not right. The population is declining, which means it's not on pace to double. So when a population has a negative growth rate, it just won't double at that rate. The population is going to be decreasing. Okay, I'm going to stop here. Just about out of time. A few more seconds. Okay, bye.